Hello, mathematicians, and today I am going to teach you the lesson 3.1 periodic phenomena. So this is in AP Pre-Calc flippedmath.com's material. This is the first lesson in Unit 3. Now, some teachers, AP Pre-Calc teachers, may start this lesson as the first unit, which is okay. So boys and girls, don't be alarmed starting AP Pre-Calc with Unit 3. Unit 3 is it's trig. You're learning trigonometry in this unit, and most students take a little more time to learn this unit. Usually a new subject, math subject for math students when entering AP Pre-Cal, especially with the memorization of the unit circle. And we'll talk about the unit circle once we get there. So 3.1 periodic phenomena. So phenomena is basically a change, something that has a constant change, a cycle, a pattern. And I want you to go ahead, and you maybe should have this notes already. I want to start with this first part of the notes. And in this notes, we have here this description of what a phenomena is, what a periodic phenomena is. So as input values increase, if the output values demonstrate a repeating pattern over successive equal length intervals, we have what is called a blank relationship, and that is called a periodic relationship. Okay, another word to describe this would be cyclical. Okay, so we have this function here, and this function is actually a sine curve. How do I know that? This is what you're going to learn in the upcoming lessons. If I was to cut it off, it starts here at the origin. Okay, so that's how I know this is a sine function. All right, so I'm going to look at this graph, and I see that it goes up and goes down and goes up and goes down and goes up and goes down, this wavelength. The way that something in the real world that we would see as a sine function would be like high tides or the phases of the moon. Those are examples. If we have the graph of a single period cycle, then we can construct the graph of the periodic relationship. The following graphs show one period of a period function. Okay, so a full cycle is a single period. All right, let's go ahead and look at what we have here. Imagine having to take this graph, number one, okay, and you were to copy and paste it multiple times, okay? So let's go ahead and take this same graph and imagine copying it here. How would you do that? It has 1, 2, 3, 4, 5, 6, 7, 8. So it has 8 units, okay? So here, from here to there is 4 units. So that means from here to there is going to give me another x-intercept. Okay, so I have one x-intercept here, one x-intercept here, one x-intercept here. For a full cycle is 8. Okay, and then half of it is 4. So I'm going to do that. So that means that it is first going to dip. And if you notice, it dips at 1, 2, that's halfway. So it dips, and look where its lowest point is. Its lowest point is at 3. So it's going to dip here. Okay, and then it's going to go back up here. And then the highest that it will ever be is at 3, and it does it at 2. So it's going to go up here. Okay. Okay, and there you have it. You should have that. I want you to go ahead and try number 2. So first, let's see. We have this, the zigzag thing here. All right, and it starts here, goes down, goes up, goes to 3, and then goes to 4 here. So its highest is constantly at 2, and its lowest is the x-axis at 1. So you want to go ahead and create another one here and try doing one backwards as well. All right, so go ahead and do that. All right, and there you go. There you have it. Okay, so it's like a copy and paste situation that you got going here. Okay, just think of it in a copy and paste. Think of how, I know many students see this differently. They count how many periods and so forth, or not how many periods, but how much units forward, how much units back to get to the next pattern. Okay, and how much units are in this one for a complete cycle? Okay, so this one has 3. So how much does it take for 1? So we have 1, 2, 3, 4. So for this one, you would have, 4. This one takes 4 units. Okay, the period of the function is the smallest positive value of k such that f x plus k. And that would be where you originally started at. Okay, so let's look at this. Identify the length of the period for each function. So what is the length of this period? What I do is I take where I'm going to pick somewhere. So I'm going to pick right at this top here. And I'm going to find on this function where it's also at that top. Okay? So it goes down, and then it starts again. Goes down, then starts again. So this is its first match where it is starting again. Okay? So from here to here, what is the difference from 3/4 and 1/4? How much is that, guys? A half. So its period is a half. All right, go ahead and try this one. Could I start at the bottom? Yeah, let's go ahead and try and start at the bottom. So I'm gonna pick a different color for that one. So if I had started at the bottom, let's say I started right here, and that's the next time that it's stops and start. So from here is a half, and here is a whole. What's the difference between a half and a whole? A half. So it works. Go ahead and try 4. Okay, so what is the period of length for this function? So where does it start and stop again? I picked right here, and I see it starts and stop right here again. So this is -4 and 12. So what is the difference between between 12 and -4? 16. All right, on the next page, Periodic functions take on various characteristics of a function, such as increasing, decreasing, different concavities, etc. Recognize that any characteristics found in one period of the function will be in every period of the function. So let's look at number 5. Below is one cycle of a period function. Use the graph to answer those questions. All right, so this is one period, okay, which is one cycle. All right, and we can have numerous of these to keep going on and on to infinity, right? Now we're going to use this graph to answer its questions. A says, is the function increasing or decreasing, or maybe both, on the interval 18 to 20. Now, if you are just starting this unit 3, in unit 1, you would have been taught about concavities and when there's a point of inflection. So your teacher might teach you that, might tell you that, to explain that to you. If we get into that, I'll tell you what that is. But because this would go in a sequence of unit 1, 2, and 3, you would have already known what concavities are and when your graph is increasing and decreasing and when it's doing both increasing and decreasing. Okay, so if I get into that, I'll explain that to you. Okay, all right. Is the function increasing or decreasing? So how do we find 18 to 20? Notice, look at your graph. It only goes to 1 to 4, and you don't have space for 18 to 20. So what you will do is, how much units is it from here to here? So this starts at 0, and this stops at 4. So we have 1, 2, 3, 4. So we know that we got 4 units to complete. And I'm going to put that right here. Now, what I'm going to do is, what will it take for me to get as close as possible to 18? All right? So how many times will I have that? So could I multiply it by 4? Yeah, I can multiply it by 4. If I multiply it by 4, I'm going to start at 16. 16 will be right here. So I'm going to put this at 16. And then this will be 17. And this will be 18. And this will be 19. And then this will be 20. So in the function 18 through 20, it's going to be 18 and 20 is going to be right here. This part of the graph. What is happening from there to there? If you said it right, yes, it is increasing. So the function is increasing. Okay, and that's it. Okay, go ahead and try B. Is the function concave up or concave down, or both, for 31 through 32? So we know it's 4 units. What do I need to multiply to get to 31 as close as possible? Can I do 6? Yeah, 4 times 6 is 24. But I can get closer to 30. About 7. 7 times 4 is 28. How about 8? 8 times 4. All right. So I could use 8 times 4, 32. It is a little over, but I need to get to 31. So that means that if I am at a cycle, 32 brings me to a cycle. full cycle and starting back at the top, I'm going to have to go back 1, which will bring me here. Okay, that'll be 31. Remember that, right? So let's do it at 28. 7 times 4 will give me 28. So that means I'll have 7 cycles. So that means 7 will give me over here 28, 29, 30, 31, and 32. Look at that. So 28, 29, 30, 31, 32. And then I'm going to go ahead and do 33. But this is also 33. They're going to be the same. Okay, so this and this will also be the same, 33. Okay, so is it concave up, concave down? 33. What is that? Exactly. That looks like concave down to me. So this will be concave down. Okay? Just like that, folks. Now, is there a relative max, a relative minimum, or neither at 0.82? All right. So again, this is unit 1. So relative max and relative minimum, you will have to know, you would have to learn that prior for this lesson, and your teacher will have to explain that to you. But I'm going to show you how relative minimum and relative max goes. But first, let's figure out what 82 is. We know it's 4 units for 1 cycle, 1 period. So how close can I get to 82? So the closest you can get to 82 is 80. So that's 4 times 20. So that means it will start right here. That means it would start right here at 80. And then this would be 81, and this would be 82. Now, what is that? Is that a relative maximum, minimum, or neither? So a relative maximum means all the highs in the graph. So we have a relative max here. So all my relative max, RM, is really high. This is a relative max. And then my relative min will be right here, R. And I'm just going to write min, okay, because they both are M anyways. All right, so this is a relative min. This is all the lows in all my graphs. So if you notice, 82 is at a relative min. All right, so this is definitely a relative min. Okay. All right, guys, and that's it for 3.1. And in 3.1, you should know how to determine the period and find the location on that graph for higher intervals or even lower ones, but on intervals that are not seen on the graph, and also understanding concavities and relative maximums and minimums within the graph for those locations as well. All right, guys. Also, if you are gonna work on the practice, please do work on the practice, of course. And I do have the practice solution videos. Check the practice solution video as well. Do them first and then check the answers, okay? Do all of them first, work through them the best that you can. This is the best way that you will learn, is not going and look at the solutions first, but just work out all of them as to the best that you can, And then where you are stuck and don't understand, you're always free to go look at the solution and then hopefully have an aha moment. Okay? All right. Thanks, guys. Thanks for watching.